This conference will now be recorded.
Okay, now we're recording so that we can put this on the website. It'll also be available on our YouTube channel. So I'm sure everybody's having a heck of a day today, right? A little mentally exhausting for all of us, I think. I think everybody just can't wait until this thing's over and done with, and we have some certainty back in our lives. I don't think anybody likes it when everything's up in the air. So we'll see what happens. All right. We'll give it a couple of more minutes. You guys feel free to chat with me via the chat feature if you want. Anything funny, any jokes, any cool stories from over the weekend, anything like that? Pass the time a little bit until we're waiting for a few more people. And let's put, this is where you type. That way you can see. All right, 3 o'clock. We'll give it another minute because I like to be on time. And then we're going to get going. That's cool with everybody here. Thank you all for being on time. Punctuality is one of my favorite things, so I appreciate you for it. All right. Let's see. You know what we'll do? It's 3:01. Get somebody else jumping in here, so that's great. And as soon as they pop up, we'll get started. We'll see if some people join us on the way. This one should be fun, thin film. All right, let's get started. So, thanks for coming to another webinar. Webinar Wednesday with Stellar Industries, kind of becoming a thing over here, and I like doing it, and I think you guys like joining them. So it's a pretty informative way to get Stellar's name and our technology out there. So we'll continue to do it. We've already done an intro video and a DBC webinar, direct bond copper. You can find those on our website. You can also find those on our YouTube channel. I also usually post links to those on our LinkedIn account. But this week, we're going to delve into thin film metallization. That's one of the 3 types of metallization techniques that Stellar uses here at our facility in Millbury, Mass. When you find those videos on YouTube, it's just a funny story. My 10-year-old is big into YouTube, and he watches video games and all that stuff, and watches other people play video games, which is pretty bizarre. But he's excited to know that his pop is a YouTube star because our previous 2 videos on YouTube now have a combined over 120 views, and I've also received 2 likes. So that's a pretty big deal. And I'm going to do my best to not let the fame, change me. So, if you need to knock me down a peg, go ahead, I can take it. So let's talk about thin film here. Essentially, thin film is exactly that, right? Thin metal films. In our case, very thin layers of high purity precious metals. Generally, these layers do not exceed a few microns. Even a few microns can be pretty thick. Thin films are also applied in customer specified metal stack-ups, right? So we're not designers, we build to print. So one of your engineers may say, we're going to need Ti platinum gold or Ti tungsten nickel gold, whatever you may need. We're going to apply what you specify. And thin films are used when very fine circuitry or geometry is required on your project. What I mean is by fine circuitry is how small are your spaces and traces and how small they can be. And thin films are also used when metal purity is critical for your application because you're only using the highest purity metals that you could possibly deposit. Now, in order to make thin film metallized ceramic substrate, right, we need to start with ceramic. Right, so in this case, let's start with some aluminum nitride. Right, you can see it's gray in color. It gives it away, and the surface finish is key when you're applying thin film. Now we're putting thin film on a variety of dielectrics. Aluminum oxide from 90% to 99.8%, aluminum nitride from 170 to 230 watts per meter Kelvin, and beryllium oxide from 280 watts to 325 watts per meter Kelvin. Also borofloat, borosilicate, sapphire. I mean, if it's a dielectric and it doesn't outgas, chances are high that we could probably put some metal on it for you. And the most important thing about the ceramic prior to the metallization is the surface finish and the cleanliness. Cleanliness is also key. But if the surface finish is too rough, you may not fully resolve your fine lines and features. As a general rule of thumb, we use polished dielectrics to accept our thin film metal deposition. And if you can see, hopefully I get a nice reflection there. You can see that nice polished finish. Generally sub 2 micro-inch surface finish. And if you have gross features or larger spaces and traces, and you require a rougher surface finish, well, we can deposit our thin films onto lapped surface finish or as fired. But our general rule of thumb is to apply these metals onto a polished surface. Let's see. And now that we have our ceramic surface finish prepared, like you see here, we need to make sure it's clean. In the lapping and polishing process for our ceramic, sometimes you're using a slurry, and that slurry obviously is going to get in the way of adhesion. So what we do is we'll clean the parts in a variety of ways depending on material. If you're working with a dirty piece of ceramic and you try to put your thin film metals on, it's going to be a really costly mistake because your adhesion will be suspect. And probably once you do your bacon tape adhesion test where you heat the part and basically use tape to see if that metal will lift, more often than not on a dirty substrate, you'll get metal lifting, which will just mean you just produced a lot of trash. So we use a variety of methods to clean the ceramic. One of them is obviously chemical cleaning. We use specific chemicals that are not going to change the surface finish that we just achieved via polishing and lapping. We also do a high temperature bake at over 1,000 degrees C. And we also use plasma cleaning. So, let's see, any questions so far? No, nothing yet. Remember, feel free to jump in if you guys have any questions. I'm happy to stop and answer them for you. All right. So now that we have our polished and clean ceramic, we decide where we're going to metallize these substrates or wafers. And here at Stellar, we have two ways to metallize them. Option one, which is our most widely used option, is EB-PVD, which is electron beam physical vapor deposition. This is a system where you have a crucible holding the precious metal pellets, and it's hit by an electron beam. And the metal pellets go molten and evaporate up into the chamber. At the top of the chamber, and let me see, I'll show you a picture. Let's see. I'll share my screen. That's not it. Sorry, I'm not as prepared as I wanted to be for this. I'll share my screen now. Okay. This is the chamber here. And in the upper portion, That's where we have a planetary fixture where all of the parts are loaded. So they're actually spinning in this vacuum chamber while the metallization is being evaporated up into the chamber. It gives you exceptional uniformity. So that is, let's see. And I am no longer sharing my screen, okay. So that is one of the methods. Metal uniformity is very precise. Typical metal stack would be, let's say, titanium, which is a seed layer, right? A seed layer, when you hear thin film companies talk about it, is essentially the glue layer, right? Some metals just won't stick on their own to ceramic, but titanium is an ideal seed layer metal. It actually forms a nice adhesion to the ceramic, especially with such a fine surface finish. Then it gives you a nice base for all of your other metal stacks to adhere. The E-beam is ideal for metallizing many substrates at one time, because you imagine in the top of that chamber that I just showed you, in some cases you can fit, let's say between 30 and 60 substrates. So for volume manufacturing, it really makes a lot of sense. We also use the electron beam physical vapor deposition chamber for our proprietary gold tin. That is also one of the offerings that we have here with our thin film. Let's see. Option 2, which is fairly new to Stellar, at least in-house. For a while, we were using some of our partner companies on the outside for sputtering services, but about a year and a half ago, we brought in a sputtering chamber, which is also a physical vapor deposition process. But this one's a little bit different, and it's pretty cool. This is where you have a precious metal target, or essentially it's like a plate of the precious metal. And then that plate or target is bombarded with ions, and atoms detach from the plate or target and collect onto the ceramic substrate. A colleague that I was talking to before I started this webinar said he had referred to it as atomic billiards, which sounded really cool. So I wanted to make sure I shared that. What's also unique about our sputtering chamber is that while we have the E-beam chamber ideal for higher volumes, the sputtering chamber is a single wafer chamber, meaning the chamber is always under vacuum. And wafers slide into the chamber through a series of doors. Then the deposition occurs on the substrate. The wafer is ejected out one side, and then a new one is sent in. This is really ideal for smaller volume runs where some of you guys may require a small amount of substrates or submounts. Where in the past, if you had said, "Hey, Jason, hey, look, I really need a substrate, a 2-inch square. I need one of them." Well, in the past, in my E-beam chamber, say I can fit 50 of these in there. You're paying essentially for all of those wafers or all the gold that gets used. With the E-beam, or excuse me, with the sputtering system, I can put in one 2-inch square wafer, okay, and you would just pay for one. So being able to buy smaller volumes or prototypes at a fraction of what we had previously quoted them. So if any of you had come to me before for small volume, come back to me because I have a much more competitive way to do this for you. Let's see. And I'll show you a picture of that too. That's pretty neat. Let's see. Share my screen. There you go. This is our Dynavac system. Very cool. We love having new pieces of equipment, especially now that if somebody needs one wafer or a couple hundred pieces, you're normally, with our other system, you'd be paying a lot charge. Let's say the lot charge was $5 grand. You were going to pay that lot charge if you got 1,000 pieces or if you got 10. Now, if you want 10 pieces, you actually could get a 10-piece price now that I'm using this new piece of equipment. Okay. So let's see. Where were we? All right. So now that we've taken our polished and clean ceramic, right? We've metallized it. You can see that difference, right? So I'm going to show you something that's pretty neat. This is what metallization looks like. See how it's kind of flat or dull, matte? That's what it looks like on a non-polished surface finish. You see here. Once you get that polished surface finish, you really get that reflectivity. It's really just a nice look to it, right? And it allows us to achieve a much finer geometry, right? Because if I have a very fine surface finish without any undesired undulation, then as I'm starting to, if I'm starting the process of removing the metal I don't want, which exposes your circuit or pattern, I don't have to worry about any real voiding, which in the case if I have a bunch of dips and pullouts or dings, because I have too rough a surface finish, some of these smaller features may not resolve properly. So that's why we always want to use polished if you're having fine lines and spaces. So that we have this, we polished it, we cleaned it, we blanket metallized it. Okay, the next step is to create your circuitry, your pattern, or your spaces and traces, if you will. And there's first a photolithography step, right, where we apply photoresist. Okay, we either laminate the substrate with dry film, or we spin on liquid resist. We'll then photo pattern, expose and develop. And what this does is this leaves areas in the photoresist that are open, which allow for the metal to be removed to now give you the pattern or design that you want. And so we start creating your pattern. That metal needs to be removed, and it's done via two methods, one of two methods. Method one would be etching back the metals. So depending on your metal stack, we have a specific etchant. That etchant is used. It infiltrates down into the spaces that have now opened up after exposure, and your metal is removed. The second method, let's see. Oh, well, let me go back to the etch back. There are some drawbacks to chemical etching of thin films, and the biggest being the inability to achieve the ultrafine features. Typical feature size with an etch back process for us would be about 50 microns or 2 mils, which is still really darn small, but in the thin film world, it's kind of a mile. So we also employ a different method if you need better features than that, or better feature sizes, and that's called ion beam milling. And ion beam milling is essentially the machining away of the metal you don't want using an ion beam. It allows us to achieve features smaller than 25 microns or 1 mil, which is ideal, pretty standard in the thin film world. We then strip the photoresist and send the parts onto dicing for singulation. And I say singulation, right, because sometimes a 2, 3, 4-inch square may have hundreds or thousands of parts. And here's an example. Let's see. I have to go back and see if I can. You can see it's probably 500 or so pieces on there, maybe even a little bit more. Now, this part was mounted on tape because once the parts are diced, you're not dicing all the way through the tape. You're dicing through the ceramic. And then we use a pick and place machine, which comes up from the bottom pops the part off of the tape, and then it's loaded into a waffle pack. That way there's minimal human touching. And in a nutshell, that's basically our thin film process and our thin film offerings. I'd love it if you guys asked me some questions about it. We obviously have the ability to do a ton of different metals, titanium, titungsten, nichrome, chrome, nickel, gold, silver, platinum, palladium, platinum and palladium, nickel, diffusion barrier metals. Platinum and palladium are used typically as a diffusion barrier between our base layer metals and our gold tin. So I would encourage you guys to call me, email me. We can talk about your design. I can send you our thin film guidelines, or you can get them on our website. That's a good question. Metal edge definition, etch versus ion beam. So ion beam milling is going to give you a much straighter edge. If you imagine when you're chemically etching away, at times you could get a little bit of a rounding of an edge. So that is certainly a disadvantage if you require a real straight edge or straight corner like that. But that's a great question. Thank you. Gives you an idea too. Here's another part where you can see the variety or the quantity of parts that we have up on one substrate. Some plated copper. You can see that mirror-like finish there. It's pretty hard to do, but we do it regularly here. Direct plated copper, plated over with gold. Those are things that we can offer you. Right now, we manufacture single emitter submounts for the laser diode world. And those are typically going to have a titanium and platinum metal stack up. And then we put down a little bit of gold, or we put down a little bit of copper. And then we plate up. We'll plate up copper to anywhere from 10 microns all the way up to 100 microns. Or the same thing with gold, but typically we're not going to plate gold anywhere, maybe 10 microns max. I mean, anything over that, if you're using gold to carry current, we're going to try and get you to switch over to copper because it's going to be a lot more cost effective. Okay, good question. Does the customer supply the substrate or does Stellar provide the substrate? We generally source all of the material for you. So we're like a soup to nuts manufacturing house. So we're going to buy the ceramic from any of the big manufacturers out there. We buy it typically as fired, and we will lap it and polish it in-house or with a company around that's local. There's a few of them out there that do lapping and polishing services. If we need to utilize their services, we do. And then, so we're responsible for all of it. Unless you have something really specific, is there an exotic material that you're working with that you need to provide to us, or would it be just a standard ceramic? All right, I guess I'm waiting for one of our attendees, most likely standard ceramic. And the chances are that we have it. I have aluminum nitride and all those thermal conductivity grades in-house, beryllium oxide and all the thermal conductivity grades in-house, aluminum oxide and all the compositions in-house from 90 to 99.8%. Ready, if it's a little bit thicker, I can always lap and polish it down. I mean, we are a build-to-print job shop. So also, if you're looking for speed, you know, sometimes you're at the mercy of the lead time and the queue time that we have here. But what we can do is look into our inventory and see what we have that may also that may already be metallized. We may have some substrates, some 2-inch squares, let's say, or some 3-inch squares that are already metallized with a standard stack up that can be turned around a lot quicker than if we had to schedule your own thin film run. So I'll always give you that option. And if you're telling me that you're in a real hurry, then I'll find something. And usually our customers can make some concessions. You know, if they were looking for 380 micron thick ceramic, but I have 300 and it's already metallized, you know, they'll say, hey, you know, I really want to get that a lot faster. I'll use what you have. And it's a much more cost-effective way to go if you're looking for speed, right? Because then you avoid expedite fees. Any other questions? Well, if you guys were familiar with some of the ways that we package parts, but in this case, I'll show you, this had some submounts manufactured and some samples are going to go out. See if I can do it without spilling them. There we go. These are some laser diode submounts using direct plated copper. That's about 75 microns thick. The material is aluminum nitride that's 380 microns thick, so 15 mils. Got about 3 mils of copper on it. And then we put 5 microns of 80/20 gold tin. This is one of the typical like waffle packs that we may pack in. Any questions out there? Come on, there's got to be a couple of questions. All right. I'll give you guys a couple more minutes to think about if you want to ask me anything else. Yes, we do have in-house plating capability, but we also use outside suppliers. What we do internally is very specific to our needs and the needs of our parent company. But in some cases, there are so many isolated pads on a part like this that if I require to plate up additional metal, I'm going to go on to the outside for the electrolysis process. But there are also times where I'll utilize electrolytic. We got a lot of great partners out there. One of our electrolytic partners out there right now is EMI Plating. They're located out in I think Evansville, Indiana. But a heck of a company, really do a good job for us. Let's see, current lead times. Well, obviously that depends on the complexity of the part. But right now we're looking at, we could probably turn thin film parts, start delivering in, I don't know, 8 weeks or so, which is pretty fast for thin film. About a year ago, our lead times were about 24 weeks. So I'm happy to say 8 weeks. What about ablation? Laser ablation? If you're looking to do like a solder dam, is that what you mean, Diana? Yes, we can laser ablate solder dams for you. And if you have a specific design in mind, shoot it on over to me or send me a little balloon shot of that area of the print. If you'd like to get an NDA in place, that's no problem. We can do that immediately, and then we can start exchanging information. Any other questions out there? Oh, you're welcome. Thanks for asking. Like I said before, these videos are available on our website in the news section. Also our LinkedIn page and our YouTube channel. My pleasure. Our next webinar will be in a few weeks. I was doing them every 2 weeks, but then I didn't think, people were interested every 2 weeks, so I've moved it over to 3 weeks. I think next time we're going to do thick film and talk about our thick film metallization process, which is a screen print and fire of conductive pastes and inks. It's one of our core technologies here at Stellar. Could be a technology that you could utilize that's a little more cost effective than thin film, but obviously it's got some disadvantages. Feature size, metal purity are not the same thick film to thin film. So I will send out a constant contact blast. I think all of you are on there, and you'll be able to RSVP and throw that into your calendar, and then we'll have fun again. I mean, I like doing this, so keep attending with me. You guys are kind of like my fuel. And if you view any of those on our YouTube page, just subscribe or like the videos. That'd be greatly appreciated. And you guys have a wonderful day. Any other questions? I'll stick around for another 30 seconds or so. See if anything comes through. I think that's it. Don't forget, head to our YouTube channel and subscribe and throw us a like for our videos. That'd be great. All right. Thanks, guys. Have a great day, and we'll see you in a couple of weeks.